Imagine you are standing at the entrance of the world's largest, most confusing maze. You want to find the exit. A normal computer, even the fastest supercomputer on Earth, solves this by trying a path. It goes down, hits a dead end, comes back, and tries another. One path at a time. It's slow. Now, imagine a quantum computer. It doesn't try one path. It exists in a state where it tries every single path at the exact same time. Boom! Exit found. Instantly. That is the kind of power we are talking about. In this video, you are going to learn exactly why this revolutionary technology is turning the science world upside down. You'll learn how these sci-fi machines work without needing a degree in physics. We'll look at the secret power of being in two places at once, and why massive companies like Google and IBM are spending billions of dollars to build them. Most importantly, you'll learn how they are about to change the food you eat, the medicine you take, and how we might just save the planet. Let's get to the value. Let's start with the absolute basics. You have to understand how different these machines are. The phone or laptop you are using to watch this is a classical computer. Underneath the fancy screen, it works using very simple logic. It uses bits. Think of a bit as a light switch. It is either ON or it is OFF. It is a 1 or it is a 0. Everything from this video to your favorite meme is just a massive combination of these billions of ON and OFF switches. It's effective, but it's limited. Now, meet the quantum computer. It doesn't use bits. It uses qubits, that is, quantum bits. This is where things get weird. The secret power of a qubit is a physics concept called superposition. Let's use a very simple example. Take a regular coin. Place it flat on the table. It is either heads or it is tails. That is a classical bit. ON or OFF. Now, spin that coin. Right now, while it's spinning, what is it? Is it heads? Is it tails? No. It's in a blur. It is in a state of being both heads and tails at the exact same time. That is superposition. A qubit can be a 0, a 1, and everything in between simultaneously. This allows them to process a staggering amount of data all at once, rather than one after the other. It's not just a faster computer, it's a completely new way to process reality. But wait, it gets stranger. If superposition makes one qubit powerful, there is another magic trick that makes a whole computer insane. It's called entanglement. Entanglement links two qubits together in a fundamental way, no matter how far apart they are. Imagine you have two magic dice. You keep one, and you send the other to your friend in Australia. When you roll your dice, you get a 6. At that exact same fraction of a second, your friend's dice also shows a 6. Every single time. They are invisibly, instantly connected. Albert Einstein called this spooky action at a distance because it baffled him. In a quantum computer, qubits are entangled. This means that if you change one qubit, the others react instantly. When you have lots of entangled qubits in superposition, adding just one more qubit doesn't just make the computer a little faster. It doubles the power. Imagine a power graph that starts low and then just shoots straight up like a rocket. That is the scaling power we are dealing with. Now, with all this incredible power, you might be thinking, awesome. I want a quantum laptop for my video games. But here is something truly strange that most people get completely wrong. If you tried to check your email or watch Netflix on a quantum computer, it would actually be worse than the computer you have right now. These massive machines, which cost millions of dollars and require conditions colder than outer space to run, are completely useless for standard tasks. So, if they aren't for Netflix, what specific problems are they built to solve? This is where they change the world. The biggest problem classical computers have is simulating nature. Nature is complex, it's chaotic, and nature is quantum. Normal computers really struggle to simulate things that exist in nature, like a molecule. Let's say we want to create a new medicine to fight a specific disease. Right now, scientists basically have to guess. They take different ingredients, mix them, and see what happens in a lab. It takes years and billions of dollars, and they might never find the right combination. Why can't we just simulate it? Because simulating a relatively small molecule requires a classical computer bigger than the observable universe. We simply can't do it. But a quantum computer is nature. It uses quantum physics to simulate quantum physics. It's a perfect match. A quantum computer could simulate a molecule perfectly in hours. We are talking about designing the perfect medicine for you based on your specific DNA. We are talking about finding cures for things like Alzheimer's, or instantly creating new antibiotics. We aren't just looking for medicine, we are simulating the future of healthcare. That is world-changing. Another massive use is something called optimization. That's just a fancy word for finding the absolute best way to do something when there are too many options to count. Regular computers get confused easily when there are too many options. Here is a short story analogy. Imagine you have a list of 10,000 football players from all over the world. Your task is to pick the perfect 11-person team to win the World Cup. It sounds easy, but the number of possible team combinations is higher than the number of stars in the galaxy. A classical computer would pick one team, calculate its score. Pick another, calculate. It would take centuries to check every combination. A quantum computer doesn't need to try one by one. Because of superposition, it could look at almost all possible teams at the exact same time and pull out the best one instantly. Now, change football players to delivery trucks for Amazon, trying to find the shortest routes globally to save gas. Or, change it to financial assets for an investment fund, trying to stabilize the global economy. Or, weather systems, trying to predict a hurricane 2 weeks in advance. These are problems worth billions of dollars that only quantum computers can solve. Let's look at one final, practical example that affects everyone watching. Fertilizer. Right now, producing fertilizer to grow food for the world uses about 2% of all global energy. Why? Because to make it, we have to use a 100-year-old chemical process that requires insane amounts of heat and pressure. It's bad for the environment and very expensive. However, scientists know there is a tiny bacteria that lives on the roots of plants that can produce the same chemical ingredients perfectly at normal temperature and pressure. It does it easily. How? We have no idea. We can't see the chemical reaction because it happens at a quantum level too fast for us to observe, and normal computers can't simulate it. A quantum computer could unlock this secret. If it does, we could make fertilizer for almost no cost, dramatically reducing global hunger and stopping a massive source of pollution. That is real change. We are standing on the edge of a new technological era. The classical computer age gave us the internet and smartphones. The quantum age is going to give us things we can barely imagine yet. Clean energy, infinite food, cures for diseases. I want you to try one simple thing today. I want you to go into Google or YouTube and just search for IBM Quantum Experience. You will see images of these beautiful, strange golden machines that look like chandeliers. They are real, and they are working right now. It is incredible to see. If you loved this video, hit that subscribe button right now. Seriously, subscribing tells the YouTube algorithm that you want brain-boosting educational content in your feed, and it helps our community grow so we can keep making these deep dives for you. Don't forget to engage with us in the comments. Want to know more about the crazy physics that makes these things work? Click this video right here on the screen to learn about the spooky action at a distance that Einstein hated. I'll see you over there.